Good morning, friends. Today I am again preparing some short questions as part 3 in continuation of part 1 and part 2. I am extremely sorry because there are a lot of typing mistakes, or you may call it printing mistake, whatever it may be, but I am unable to edit or correct all these due to present pandemic situation. I shall be grateful if you kindly bear with me for these mistakes. Whether these short questions appears to be useful for you or not, I am not sure, but I shall be grateful if a little fraction of these short questions is becoming some useful to my beloved young engineers and student engineers. Today I am starting from a single span bridge. The question is, a single span bridge of 40 meter wide with design discharge of 1500 Qmax and minimum depth of foundation at RL 50 meter, considering a scour analysis with a grip length of 33% extra as per ISO 78. This is our feedback. Is there any further requirement? This is the question. Further requirement of addition step shaking for safety of the bridge. From hydraulic analysis, we can select the minimum depth of foundation, which is recommended as 33% over scour depth. And there are a lot of shaking, active earth pressure versus passive earth pressure. Equation is active earth pressure, passive earth pressure equal to 0. And soil bearing pressure, settlement, and lot of other things, including construction feasibilities. A lot of things. There are step shakings are very much essential. In this giving ensure is, these are the giving ensure. First, number 1, no further shaking required. Soil pressure shaking. It is minimum depth of foundation from scour analysis, so all other condition shaking is there. 33% is safe enough. None of these. The correct answer is, it is minimum depth of foundation from scour analysis, that is hydraulic analysis, so all other step shakings are necessary. This is the answer. Next question. In most of the bridge, circular well foundation are provided. What is the advantage of circular well foundation? Given answer is sinking, suitable for sinking for due to lesser wall friction, less concrete quantity, minimum flow obstruction, no reduction of waterway, none of this. The circular well having lesser wall friction, so it is more suitable for sinking operation. Suitable, correct answer is suitable for sinking operation due to lesser wall friction. If we go for rectangular well, then friction will be more. So we are providing circular well. Nowadays, wall foundation are replaced by pile foundation, mainly two reasons: economy, number two, speedy works. In case of pile foundation, what shall be the minimum pile diameter in pier foundation? In well foundations are provided in a river valley, river. So in river there are two type of foundation. One is abutment foundation, another is pier foundation. Pier foundations are in midstream. So given and what diameter is suitable? Diameter, minimum pile diameter, and given answer is 1 meter, 1.5 meter, 0.75 meter, 2 meter, and none of these. In abutment foundation, in case of abutment foundation, 1 meter to 1.5 meter can easily be provided. But in case of pier foundation, we have to provide minimum 1.2 to 1.5 meter. Since there is no 1.2, so the correct answer is 1.5. 1.5 meter. We have to provide minimum 1.5 diameter pile in pier foundation. In case of pile foundation for a bridge, whether 33% extra over maximum scour depth is sufficient. Given answers are number 1, no. Number 2, yes. Number 5, 1.5 meter, 1.5 times extra. Number 4, 2 times extra. Number 5, none of these. No. We have to check pile load capacity, pile resting soil formation, and group settlement, lot of other things. So this is not simply 33% over maximum square is not sufficient. The answer is no. In the river bed, the top portion of piles are unsupported soil. Since there is no soil along the pile shaft, whereas the horizontal load carrying capacity is governed by the soil parameters of 1/3 top mantle of pile length. 1/3 top mantle of the pile length. In such cases, In such cases, which soil shall be generate the horizontal load? In analysis, given answer in analysis, load shall be resisted by concrete strength, soil below the maximum cover depth. It is assumed that the horizontal load pile produced by uplift of the pile, soil up to the depth of fixity, none of this. In estimation of the horizontal load of pile is generally governed by 1/3 of the top mantle of the pile, soil of top mantle of the pile. But the piles, the top mantle means it is from its cover level to depth of fixity. The soil up to depth of fixity. Correct answer is soil up to the depth of fixity, from the maximum its cover level to up to the pile fixity depth. Pile fixity depth, it may be 5 times dia, it may be 4 times dia. Generally it is 5 times diameter below HFL. It is called depth of fixity. And from the soil subgrade reaction modulus and concrete strengths, this up to the depth of fixity, we can calculate the horizontal load of pile. A 10-meter wide seasonal river, seasonal means not perennial river, stream, having rocky bank at both sides, what type of foundation shall be suitable? Shallow, given answer is shallow open foundation, RCC box culvert, or shallow raft foundation. It is a seasonal river. It is not perennial river, and both sides is khadir. Khadir means inerodable rock bus bank. May not be intact rock, but it is a rocky bank. So there is no question of any scour. The best suitable option is shallow open foundation at both abutment. And next question, a few years back, a hydroelectric dam opened their gates and huge amount of water was allowed to pass out, resulting huge damages of public properties and washed away 3 major RCC bridges. Why the bridge? The question starts from here. These are the information. Why the bridges were not designed for higher discharges? Answer given. Design discharge fixed as per IRC guidelines. IRC has specifically recommended that the extra design due to failure of a dam or reservoir shall not be accommodated. Number 3, should be considered. That means extra discharge should be considered, considering cost factor. None of these. Here you see, it is a fact. It was happened in 2006. Damages 3 major RCC bridges, 4-span, 3-span major RCC bridges with well foundations. But you see, In IRC, there is a specific recommendation that extra discharge due to failure of a dam or reservoir shall not be accommodated. We are required to calculate the design discharge as per IRC 5 and IRC 13, SP 13, and finally all guidelines of IRC 78. In IRC, specifically recommended that extra discharge due to failure of a dam or reservoir shall not be accommodated. So question does not arise to adopt higher discharges. Next, a Minda river bed of 180 meter wide and uniform depth is 1.8 meter. What type of effect shall be more? Heavy bank erosion, bed scour, heavy bank erosion, change of river flow, shifting of river course, and none of this. All shallow rivers, 1.8 meter means a man height. These are shallow rivers. All shallow river has a tendency of bank erosion because there may be some materials at river bed which is not easily erodable. Bed scar will be very not prominent because that material may be cohesive or may be rocky. So it is very easy to make bank erosion than the bed scour. So answer is heavy bank erosion. Today it is, if it is 15 meter, next year that river will be 20 meters. So bank erosion will be always there. Next, a flashy river with a bed slope of 1 in 20 at foothill, carrying a flood discharge of 15,000 cubic. 15,000 cubic. What type of destructive activities when the river reaches a plain land having slope of 1 in 2,000? Widening of width, answer, widening of width, formation of minder, bank erosion, bed scour, none of these. Since it is a flashy river, water shall be immediately eroded some bank one side, and again after sudden recede of Eiffel flood water, again that deposited material shall be deposited at downstream. Again next flood will be coming, that deposition will be there, it will go for making bank erosion. So there shall be resultant shall be formation of minders. This is the answer. There shall be formation of minders. The river carries suspended load of 10 million tons per year. What type of behavior is generally noticed in this type of river? Given answer is formation of sandbar, bank erosion, changes of river course, formation of minders, none of this. These heavily suspended the river carries heavy suspended loads. 10 million, it is not a matter of joke, 10 million per year. It is almost per year, one per month, it is 1 million. It will be more than that, April to September. During April to September, it is 10 million. So, how much suspended materials carried? This type of river generally making sandbars. What happened? Flood carried the suspended load, silt and fine sand, silt, and when velocity will be decreasing, some amount of silt will be deposited at lower bank, like a formation of river island. That type of formation shall be there, and when again it will be, when flood will come, then carry some amount of silt and it will be deposited at some downstream. So, formation of sandbar. Sandbar and river island. Difference is sandbar can be washed away by some next flood or sometime later, but island is a permanent sandbar in midstream or side or whatever it may be. That is island, and sandbar, those can be easily eroded. Next question. A microwave tower of 150 meter height having dead load of 120 ton. It is dead load. Thrust is 1200 ton. These loads shall be distributed to 4 legs. There 4 legs shall be provided. The net SBC of soil formation has been calculated as 20 kg per cm square at a depth of 1.5 meter below ground level. And net SBC has a tendency of increasing with depth. If we go deeper, more SBC we will get. Net SBC, not gross SBC. Net SBC we shall be, there has a tendency of increasing with depth. Considering the high horizontal load, what type of foundation shall be safe and economic? Given answer is raft foundation or board cast in situ foundation or wide footing foundation or under pile foundation. What type of foundation? Or none of this. For in this kind of, when this is too less and it is too high, it is 10 times more. So in that, if we go for monolithic structure, it will give more rigidity against both dead load and uplift, because base will be giving sufficient resistance, sufficient weight will be there, that will be acted as a resistance, and soil is good enough, 2 kg, that is 20 ton per meter square. So we can easily provide. Best economic and easy solution is raft foundation. A RCC 4-storied building having column load varying from 80 to 120 tons. Each column carries, some column carries 80 tons, some 90 tons, some 100, some 120 tons. the foundation up to a depth of 5. Foundation soil. Here it is soil. There is a mistake. I again sorry. Up to a depth of 5.5 meter declared unsuitable for these loads. What type of foundation shall be suitable for this building? Answer is raft foundation, floating foundation, pile foundation, strip foundation, or none of these. None of these. When 5.5 meter soil has no sufficient SBC, we cannot go for other foundation except raft foundation, except pile foundation. We should provide pile foundation is there. Pile foundation there. It will be best suited alternative. A building was designed with a pile foundation considering a compression load of 70 ton per pile with a safety factor of 3 and uplift load of 82 ton per piles with a safety factor of 6. During initial pile load test results reveals about 25% higher loads both on compression and uplift. During construction, a lightweight structure was constructed which results about 10% of higher load than the original design load. A safety certificate is necessary for insurance purposes. What is the opinion of the design engineer? Safe, unsafe, just at tolerable limit, may fail at any time, none of this. Now you see, here you see, during load test we are getting 25% extra over the design load, and here at the estimation, at the time of estimation, we are adopting a safety factor of 3 which we can reduce up to 2.5, and uplift load, here it is adopted 6 and we can reduce it to 4. Further, it was additional benefit that load test results give us 25% higher values than the design load. As such, this 10% overloaded is permissible and safe. So, answer is safe. A structure was designed for uplift load of 120 ton with a pile foundation of 500 mm dia, 15 meter long, with uplift load of 40 ton per piles. The working load estimation procedure, it was clearly stated that uplift load equal to surface area, skin resistance, and with a safety factor. Now, there are any possibilities of increase of safe uplift load, and up to what extent? Given results is 4.42, 7.36, 9.5 ton, and none of this. You see, we can increase in this equation, AS in AS and skin friction resistance and safety factor. These are factors are there. So we are getting safe uplift load only. But the load of the self-weight pile shall be acting against the uplift forces, so it will be included, it shall be included. We can increase, but not it is 4.42 complete weight of the concrete we have to include. So our answer is none of these. We can increase, but none of these. A residential building was designed with pile foundation for compression load of 50 ton pile with 4 numbers pile in a group. Piles are 500 mm diameter, 12 meter long, resting on dense compact sand refusal envelope. Refusal envelope means it is more than 100. Now question is, now how much deduction of pile load as per pile group geometry 2 by 2, 2 piles in group, 2 piles in row and 2 piles in column, and spacing is 3D, 3 diameter spacing. So it is standard spacing, it is not close spacing. Given answer is no reduction of load, 5% reduction of load, 10% reduction of load, 15% reduction of load. These are normally there is a condition of reduction for group efficiency. There are a lot of group efficiencies which is varies from 0.8 to 0.95, 0.9 or even nearest to 1 considering the spacing, pile spacing and pile diameter numbers, pile group geometry. In a sense, pile group geometry we have to check the efficiency factor and we have to make some amount of reduction of piles in group. But another condition is there when pile is passing through any type of soil and resting at dense hard deposit, progressively drains hard deposit where no reduction is necessary. So here it is refusal envelope. In case of sand, required envelope is greater than, for class 1 type of sand, envelope more than 35 is considered as class 1 type. So class 1 soil, no reduction is necessary. Envelope is refusal more than 100. A building was designed for a pile foundation for uplift load of 50 ton per pile. The piles was resting on hard consolidated clay class 1 soil. The safety factor for compression it is 2.5, adopted as 2.5. What safety factor was adopted for finding out uplift load of 50? You see, question is safety factor. Although this is question is safety factor, finding out load it is secondary issue. It is secondary issue. So Given answer is 4.5, 5, 6, 2.5, none of above. From if it is compression 2.5 was adopted, then for uplift 2.5 divided by 0.7, it shall be 3.6. It shall be 3.6. Here it is 4.5, 5, 6, 2.5, none of above. There is nowhere it is 3.6 because here another reduction of 70%. 0.7 it should be multiplied by 0.7. So there is 3.6 against this compression safety. 3.6 will be uplift safety factor. So here it is given 4.5, 5, 6, 2.5, none of above. So our answer shall be none of above. This is our answer. What is the relationship between the pile shelf weight and pile load carrying capacity? Option is given. A, for compression load, given result is no relationship. Pile weight should be included with ultimate compression load. Pile weight should be included in safe compression load. Pile shelf weight should be deducted from the safe compression load. In case of compression load, the pile shelf weight of the concrete, the pile have some dimensions. For it helps some shelf weight, though that shelf weight shall be deducted from the safe compression load. That means that load is already there. So the pile shelf weight should be deducted from the safe compression load. For safe uplift load, no relationship. Pile shelf weight should be included with ultimate uplift load. Pile shelf weight should be included with safe uplift load. Pile shelf weight should be deducted from the safe uplift load. None of this. Here, the pile weight shall be additional load to resist against the uplift forces. Uplift forces, the load will be acting against the uplift forces, so it shall be included with the safe uplift load. In case of compression load, this load is already there, so it shall be deducted. In case of uplift, the load including pile load shall be uplifted, so it will be included in safe uplift load. This is the difference. In compression load it will be deducted, in uplift load it shall be included. A bridge was designed for pile foundation. The low water level is RL 52 meter. Lowest bed level is RS 50 meter. Maximum scour level is RL 40 meter. And pile termination level was 24 meter. Fixed at 24 meter. Steel liner considered necessary for safety of the pile workmanship. Up to what depth? Question start from here. Length of the steel liner provided RL 24 or RL 40 or RL 50 or RL 45. See, pile was terminated at this much, and our maximum scour is RL40. So we have to provide steel liner up to RL40, since the pile will be under exposed condition up to RL40 meter. That means up to maximum cover depth pile shall be exposed. It is theoretically exposed, so we are required to furnish this maximum cover level as per necessary steel liner. We are required to provide RL 40 meter cover level. A tower foundation of a transmission line 800 kV direct double circuit proposed to be constructed on a gravelly river bed with pile foundation. The adopted design parameters: HFL is RL62, low water level is 57, scour level is 51, pile termination is RL33, and steel liner was up to RL51. You see, RL51 means maximum scour level. And the piles are designed for a safe uplift of 350 ton per pile. During construction, due to site condition, steel liner was provided up to RL 33 meter. That means up to the pile full length steel liner provided. Whether the pile is safe for uplift load of 350 ton per pile, safe, unsafe, safe but long-term settlement may take place, sunset of shear failure, none of this. I will say our safe load depends on skin resistance, which is derived from frictional resistance of soil up to this stem area, that is pi d, and length, and shear strength S. There is another component, soil concrete reaction coefficient. For frictional resistance, we require one coefficient, soil concrete reaction coefficient. Soil concrete reaction coefficient we are generally considering as 0.5. But in case of steel, soil concrete reaction factor is 0.25 to 0.27. That means it is half of the total load. So it is unsafe. 350 was design load we have derived considering is a skin friction coefficient of 0.5. In that place we are getting 0.25 to 0.27. It is 50%. So it is unsafe. It is totally unsafe. A well foundation during sinking operation suddenly stuck due to presence of bedrock resulting tilting of 1 degree shifted by 450 mm Both are not permissible and unsafe. Finally, it was decided for composite foundations for additional load due to tilting and shifting. What type of composite foundations are safe? Well and file, or well and smaller well inside, well and rock anchorage, one extra pile at downstream and one extra well at upstream with combined well cap, and none of above. So it is unexpected one extra well at upstream and downstream. So it is number 4 was deleted. Number 1, well and pile. Well and pile. So since it is already tilted because of due to presence of hard rock, so pile we may not able to penetrate during pile installation. It will be very difficult to drill the rock surface, say about 10-15 meters for required loading. So it will be very difficult for pile foundation, and so it is also ruled out. Well, smaller well and smaller well inside. It is the same thing. If we go for one smaller well inside, after a certain time, that well will be again tilted because of bedrock is there. So it will be same problem. The only remaining well and rock anchorage. Well and rock anchorage. For rock anchorage, we require say about 6-inch diameter rock drilling, say about 10-15 meter, whatever it may be as per requirement. So it can be rock drilling can be made from the top of the well, so we can anchor with some cable and pre-stress later on. So well and rock anchorage will be the best option. As stated in A, this was happened in northeast India about 20 years back. Which was the name of that bridge? Siang Bridge of Arunachal Pradesh, Barak Bridge of Silchar, Brahmaputra Bridge at Tazpur, or Brahmaputra Bridge at Jogighopa, or none of this. This is Brahmaputra Bridge at Jogighopa at Gwalpara, Assam. It is located about 160 km east of Guwahati. The bridge is called Naranarayan Setu. Naranarayan Setu. Naranarayan was the founder king of Kush Raj, Kamta Raj, Kush Raj. So after his name, the bridge was dedicated and named as Naranarayan Setu. It was located in Jogighopa at Gwalpara, Assam. In pile load test, maximum loading was applied up to 2 times of the net working load against adopted safety factor up to 2.5. You see, that's the most important question. In theoretical analysis, we are adopting 2.5 as a minimum safety factor, but in pile load test, we are going up to 2 times loading only. Why? Given answers are IS 2911 part 5 suggested safety factor 1.5 against 12 mm settlement, suggested a safety factor of 2 against a settlement equal to 10% of pile diameter. It is simply physical verification of theoretical estimated loads. A safety factor of 2 is safe and adequate, none of this. The pile load tests are conducted up to 2 times, although in theoretical analysis we are adopting minimum safety factor of 2.5 because there are conditions during applied load. There are 2 steps, which shall be the safe load, which shall be the safe load. Safe load, there are 2 options. Earlier there are 3 options. That is, the earlier options are with a safety factor of 1.5 at 12 meter load, 12 mm settlement, load at 12 mm settlement with a safety factor of 1.5. Another is load at 10% pile diameter settlement with a safety factor of 2. And number 3 was residual settlement, load at residual settlement of 3 mm. These are 3 options are there. Nowadays, there are only 2 type of estimation procedures. The 2/3 of load, safe load equal to 2/3 of ultimate load at 12 millimeter settlement, or 50% of ultimate load at 10% pile diameter settlement, whichever is less shall be considered as safe load. So this answer is IS 2911 part 5 suggested a safety factor of 2 against 10% of settlement. Next question. Generally in cohesive soil, when phi is 0, NC value was considered as 9 for estimation of pile bearing capacity, pile load capacity. This is 9. In equation, this CNC and alpha reduction factor, surface area of the pile, and C. Whether depth factor and shape factor has no influence in pile foundation. The given result is no influence in case of phi 0, neglected since it is negligible influence. These are carefully considered. End bearing is negligible for cohesive soil. 5. None of this. You see, when phi is 0, normal shallow foundation equation C and C, Q and Q. Q in shallow foundation equation, Q q n q plus half b gamma n gamma, that portion is became useless. So only n bearing capacity C is NC. C and C. NC is considered as 9. NC is considered as 9. And this reduction factor 0.5 ASC. When phi is 0, there is all other factors will be automatically for skin resistance. All factors will be 0. So C will be only there. So it is. So there these are. Our question is whether depth factor and shape factor has no influence. Yes, these have sufficient importance and influence in pile foundation, and these are very carefully considered. Phi equal to 0, NC, DC, SC. 8.89, which is rounded to 9. It is rounded to 9. And here it is no influence. It is no influence. So, is it clear now? It is already considered. In static equation, earth pressure coefficient K is entirely based on frictional angle phi and soil concrete reaction coefficient alpha. Value of earth pressure coefficient was calculated as 1.5 considering phi equal to 30 degree. After detailed investigation, phi equal to 39. Under this condition, what value of K can be adopted as suggested by IS specification? Given answer, this earth pressure coefficient is generally calculated from the passive earth pressure equation. 1 plus sin phi divided by 1 minus sin phi into soil concrete reaction coefficient of 0.5 more d phi more d earth pressure coefficient K. When it is 30, 1.5 was adopted. Then they are getting, after detailed investigation, they are getting 39. It shall be generally increasing. But we are bound to follow all the conditions of here it is clearly mentioned that IS specification. Here it is clearly mentioned IS specification. In IS specification, our maximum permissible limit is 1.5. It is clearly mentioned in K notation. It is considered, it shall be considered as 1, and finally it can increase up to 1.5. So we are bound to follow the restriction of IS. We cannot exceed this. As stated in E, in this question, simply after replacing IS specification by IRC specification, what shall be the K value? It is 2.2, 1.8, 1.5 or 2. None of these. You see, same conditions. But here, instead of IS, it is replaced by IRC. It is replaced by IRC. In these cases, we can adopt is 1.8 because in IRC 78 K value can be taken up to 1.8. Next, soil formation is same. Soil formation is same. Phi is 39, and here IS is, as per IS it is 1.5, and as per IRC it is 1.8. A pile was designed for a net safe load of 50 ton per pile with a safety factor of 2.5 against an anticipated settlement of 18 mm. During initial load test at 12 millimeter settlement, load was recorded as 90 ton per pile, and at settlement of 10% of pile diameter, load was recorded as 130 ton per pile. With help of load test data, how much load capacity can be adopted? 50 ton per pile, 60 ton per pile, 55 ton per pile, 65 ton per pile, none of this. You see, we are getting from this, we are getting 60 ton. Here it is, we are getting 65 ton. But condition is, load test is not a designing criteria. Designing criteria, we are in static analysis, we are considering unsupported length and 50% reduction in skin resistance, and during load test we cannot create the static conditions requirement, unsupported length, reduction of shear strength, and soil concrete reaction of 50%. We cannot create that situation. So we have to adopt 10 ton per as per original design. It was our original design. We have to adopt the same load, because this load test is theoretical verification of practical verification of theoretical estimates. Today I am finishing this here itself, and I look forward to give you some short questions in the coming days, and I am always available at jcgogoi@gmail.com. I am saying once again, jcgogoi@gmail.com. Wish you all the best. Wish you very, very happy and safe time. Please have a nice day.